This video is in continuation of my last video. Here I going to solve few problems relating to hydrogen ion concentration and pH. Before that, I quickly recap the problem solution portion of my last video. Problem 1 was we have to identify hydrogen ion and OH minus ion present in 250 ml of a solution of pH 3. So pH is given, so we can easily identify the H plus ion concentration by using pH is equal to minus log of H plus concentration. So pH is known, it is 3. pH known, it is 3. So we have to identify the hydrogen ion concentration. So as we know that 1 molar of a solution contains 6.023 into 10 to the power 23 ions per liter. So this amount hydrogen ion concentration contains this much ion per liter, but the solution has 250 ml, so you have to divide this result by 4, so we get the desired result of hydrogen ion present in 250 ml of a solution having pH 3. But for identification of OH minus ion, so we just use this formula, H plus concentration into OH minus concentration is equal to 10 to the power minus 14. So from here we have to first identify the OH minus ion concentration, and rest will be the same. So we have already identified that OH minus concentration is equal to 10 to the power minus 11 molar. So we just use that 1 mole contains 6.023 into 10 to the power 23 ions per liter, and from then we have to get the desired result. So problem 2 contains, actually you have to identify pH of 4 types of solution. So in our last video we have solved the first two. The first one is HCl. HCl, it is a strong acid, so it dissociates 100%. So we know the formula, pH is equal to minus log H plus concentration. H plus concentration is given, so it's very easy to get the result. For OH minus, we have already discussed that we have to use this formula for OH minus, and here for NaOH solution, OH concentration is given, OH minus concentration is given 1 mole. So from here we have to identify the H plus concentration. When we got this result of H plus concentration, then pH identification is very easy, and we got the pH. Now we are going to solve the rest two problems under this problem number 2. So you have to identify ammonium hydroxide, pH of a solution of ammonium hydroxide and acetic acid. And both ammonium hydroxide is a weak base and acetic acid is a weak acid. So they do not go 100% dissociation or ionization. So in case of problem number C, the ammonium hydroxide ionizes as NH4 plus OH minus. So we consider that let alpha is the degree of dissociation and initial concentration of ammonium hydroxide is C. That means if from the mass action law Kb, we know that it is so initially from this equation I just write here the initial concentration is C and we consider that alpha is the degree of dissociation. That means C alpha will be, this portion will be dissociated. So the concentration is, this is C alpha and this is C alpha, and this will be initial concentration C and this is dissociated, we just minus it from here. So C is equal to 1 minus alpha. So we just use this value here. So this is C alpha into C alpha, this is C into 1 minus alpha. Just cancel up C, then it become C alpha square divided by 1 minus alpha. Now this alpha is actually very less, so we just ignore this portion. So alpha is equal to, we can identify this as Kb by C. Now Kb we got it from our question, that Kb is equals to 1.85 into 10 to the power minus 5 and divided by C is initial concentration. Initial concentration is 0.1. This I got from here. So alpha will be 1.34 into 10 to the power minus 2. So once I identify alpha, then we can identify C alpha, that means OH concentration. So OH minus will be C alpha and this is 0.1 into 1.34 into 10 to the power minus 2. That is 1.34 into 10 to the power minus 3 molar. So if we know the OH minus concentration, so by using this formula, that is H plus into OH minus is equal to 10 to the power 14 minus 14. So by using this value we can identify, you putting this OH concentration value here, we got the result of H plus concentration 7.46 into 10 to the power minus 12 molar. So pH is equal to, we know that pH is equal to minus log of H plus concentration. So we got the result 11.13. Now for D, we solve this problem, fourth problem. So this is, acetic acid. Acetic acid also weak base, weak acid. So here we can identify similarly Ka is equal to C alpha square. So alpha is equal to Ka by C. Ka is 1.85 into 10 to the power minus 5, and this is 0.01. So alpha will be 4.3 into 10 to the power minus 2 molar. So if alpha is known, so we got H plus, because acetic acid CH3 COOH dissociate, so this is C alpha. So H plus concentration is equal to C alpha. The C we know, and alpha is 4.3 into 10 to the power minus 2. So H plus concentration is equal to 4.3 into 10 to the power minus 4 molar. Then pH is equal to minus log of this, so it is 3.367. Now, so in problem number 3, this is our last problem on this pH. Calculate the pH of a 1 into 10 to the power minus 8 molar solution of HCl. So our general tendency of calculating pH is, we have to use this formula. pH is equal to minus log H plus concentration. So here this is H plus concentration, so I put this value here. So pH is 8, but it is obviously incorrect, because no matter how much one dilutes a strong acid, the solution never become alkaline. So then what we have to do, in a very dilute acidic solution, H plus concentration of acid and H plus concentration, H plus ion concentration from water are comparable. So the concentration of H plus from the water cannot be neglected. Therefore, H plus total is equal to H plus from acid and H plus concentration from water. So as this HCl is a strong acid, so consider that 100% dissociates. So the H plus concentration from HCl will be 1 into 10 to the power minus 8 molar. Now we have to identify the H plus concentration from water. So water, we know for pure water it's also 100% dissociates, H plus and OH minus. So this H plus ion of water is equal to OH minus of water, which consider it as X. So this is X. So H plus total is equal to, for HCl we got this 1 into 10 to the power minus 8, and from water this is X. So we know that H plus concentration into OH minus concentration is equal to 10 to the power minus 14. So this H plus concentration is 1 into 10 to the power minus 8 plus X, and OH concentration, from this equation we know that both are same, so H plus and OH minus for water, and the source of H plus is from water, so this is X, 10 to the power minus 14. So here we know that X square, plus 10 to the power minus 8x is equal to 10 to the power minus 14. So X square plus 10 to the power minus 8x minus 10 to the power 14 is equal to 0. So we have to calculate from this equation to X. So I rewrite the equation here again. X square plus 10 to the power minus 8x minus 10 to the power minus 14 is equal to 0. So we know that if the equation is ax square plus bx plus c is equal to 0, then x is equal to minus b plus minus root over b square minus 4ac divided by 2a. And in this equation for this equation, A is equal to 1, B is equal to 10 to the power minus 8, and C is equal to minus 10 to the power 14. So by using these values, we get x is equal to 9.5 into 10 to the power minus 8. 9.5 into 10 to the power minus 8. And we neglecting the negative value. There is two, we got, by using these values, we got two answers, two value of x. So we neglect the negative value. So we get this x. So 1, we got x, then h plus total we can easily identify. So h plus total, what was the equation? H plus total was h plus from HCl and h plus from water. So h plus from HCl will be 1 into 10 to the power minus 18, and h plus from water is this, because we consider it as x. 10.5 into 10 to the power minus 8. From this equation, we got 10.5 into 10 to the power, what is this? This is 10 to the power 8, and this 10 to the power minus 8. So pH, we know the pH is equal to log of H plus concentration. So use this. So from here, got the result is 6.978. So it is almost neutral. Thank you. Thank you for watching this video and your patience.